Hello again, it's Paul, and I'm back to talk about fission and why we really need to know about fission as reactor operators. Fission, in its simplest form, is the splitting of a nucleus to produce energy. And we need to split a number of nuclei in our nuclear reactor in order to produce a constant amount of power. And hence we need to know about fission, how to control it, and what the products of fission are. As we've seen from earlier parts of the course, there are subatomic particles that make up our nucleus, and they're called neutrons and protons. In our PWR, we use the neutrons to interact with other nuclei, such as uranium-235, to split or fission it. And this gives us a release of energy and more neutrons. The neutrons in our reactor core can come from a neutron source, which is something we'll cover later on, the decay of radioactive material in the fuel, and once again that will be covered later in the course, and our neutrons that have been born from fission. The animation that is about to play on screen will give you a good visual demonstration of what's actually happening inside the fuel rod during a fission event. As we zoom in, we can now see our neutron being absorbed by fuel, uranium-235. Neutrons that are absorbed by uranium-235 are normally thermal, or what we call slow or low energy neutrons. This makes the nucleus unstable or excited, and in this excited state the nucleus begins to reorder itself and can become elongated. This elongation means the two ends of the nucleus no longer attract each other, producing a dumbbell shape. And now our nucleus can break apart, resulting in two fission fragments. As well as fission fragments, we also get an average of 2.4 more neutrons, gamma radiation, and approximately, importantly for us, 200 MeV of energy. The neutrons that are produced from fission are high energy, termed fast or prompt neutrons. And in order to produce more fission events, these neutrons will have to be slowed down through a process what we call moderation. Moderation will produce more thermal neutrons in our core and therefore produce more fission events and sustain that chain reaction for power production. And moderation is something we're going to cover in the next session.